Okay, the right answer. I got my first star. Yoo-hoo. That was horribly complicated to implement, but I managed to do so. I'm kind of proud now. So, 20 seconds to go. Guys from Germany will solve day 16 of Advent of Code. Watch and learn, dear audience.
Good morning, dear viewers. 8 seconds and counting.
So, here we go. Proboscidea
Proboscidea
volcanium, whatever this is.
does have to do something with a volcano. That's for sure.
So, caves and signals. Some elephants.
Defense.
30 minutes before the volcano erupts. Scan the cave, okay. Pipes and pressure values. But I don't care. So this thing has a flow rate. This is important. Okay, it's kind of a grid, and so these valves are kind of the edges, and no, the valves are the vertex, and then there's a tunnel. But why has the valve a flow rate and not a tunnel? Okay, I will implement a parser and then read it again. Okay, looks like a dynamic programming here. We need to find kind of, so we need to find in a final a path to walk somewhere, and then most likely everywhere we walk we open the valve. So the question is which valves in which order do we open, and this is actually the path we search for. So so what we can think of is a path of a certain length, say length x. So it's always optimal to have, no, we have to kind of find the shortest path of a given value. Or how is it?
And we have to visit the valves that have a flow rate bigger than 0. The others are not important.
Yeah, of course.
AA.
Of course. So the importance of the valves is the flow rate they have, but this is only a number. So this is, so 0 valves are not special in any way. Only that it's multiplied by 0 is still 0. But the point is here, the brute force solution would be to check all paths, and this won't be possible because it's too much of these valves. It's simply too much paths to check them all. So we need some optimization here. So I got a possible solution for me. So this won't be too simple to implement, but it would work, I guess. Do you have a good idea, Achim?
I'm probably making a mess out of it.
What's your idea to solve it? Brute force? Sounds like brute force.
My idea is, okay, I have a starting point, I have multiple possible paths that I can go, so with every step I increase the number of paths I can go.
Yeah, okay, this is basically a DFS, so you pass all, you create all paths and then check them, each one, what it gives as a result. So
it is probably brute force, and
well, it will come to an
I
end.
need to throw in proper check that when I have opened all relevant valves that I stop running around. Just let the time run. Because in that case I don't need to create more paths, which would essentially kill the entire solution.
So I just submitted my first answer. Of course it was wrong, but at least my thing runs kind of fast. So now I have to debug it because it's not correct. Ah, it works for me for my test input. Now I will run it for the real input. Or maybe I should have. So it dies here. Hey, the right answer. I got my first star. Yoo-hoo. That was horribly complicated to implement, but I managed to do so. I'm kind of proud now. Whoa, top 1000. Yoo-hoo.
Oh, nice.
Position 816. No, okay, let's try second part. I guess this will even much more complicated. Oh god, I don't want complicated problems.
Part 2 is a lot more uglier than part 1.
Yeah, well, you will see once you open it. Well, basically, I can phrase this. Basically, in part two, you get kind of a friend, and then the 30 minutes becomes 26 minutes, and you both run in parallel through this grid and try to do the same,
Oh,
maximize this value.
interesting. Anyhow, I need to think about this puzzle some more and uh, so I will now terminate my recording. So, have a nice day.
Have a nice day, Achim. Goodbye.